All right, group, we are still on page 1 of our Solve by Factory notes. We're going to do numbers 3, 4, and 5 together. So here we have to do split the middle again because we have a trinomial. So here we need to multiply to negative 36 and add to negative 5. So for 36, we could do negative 6 and 6. We could do, let's see, 9 and 4. We could do 36 and 1. It looks like negative 9 and 4 would add to negative 5. So we're going to use those two numbers and split our middle term. Okay, so we keep those first two terms the same. We split that negative 5x into negative 9x and 4x. And now we can group and then do our GCF. So here we have an x in common. And we factor that out. In our second set, we'll have a 4 in common. And we'll factor that out. Remember, your parentheses should be the same. Whatever is in your parentheses is one part of your answer. And then those two GCFs, you put those together to make the second part of your answer. Now we're going to use our zero product law. Set those guys equal to 0. And then we want to get x by itself. So our first one, we add that 9 over. We get x equals 9. We subtract our 4 over, and we end up with x equals 4. Oops, I'm sorry, negative 4. Here we go. All right, let's check this in Desmos and get the minimum value as well as the domain. Okay, so x squared minus 5x minus 36. The minimum value is kind of like the vertex, however, value is always the y value. So here the minimum value is negative 42.25. Okay, we don't list that whole point, just the y value. If you want to put y there above it, you can to remind yourself. And then our domain for a quadratic, if I zoom out, you can kind of see, if I was able to draw on here, I could draw arrows, right? So this would go on forever. So it's going to go forever to the left and forever to the right. So when we're talking about x values, it's never going to end on the left or the right hand side. So this would be negative infinity to positive infinity, or you can say all real numbers. All right, number 4. Okay, so this one is has two different terms. So we know it's not going to be split the middle. It's going to be somewhere between GCF and difference of squares. So for difference of squares, we have to have two terms, and we have to have subtraction. And we have that. So we have two terms, we have subtraction, and 25 is a perfect square. We can take the square root of it, same thing with x squared. So this will actually be a difference of squares problem. If those things would not have checked out, then we would do GCF. Okay, when we do difference of squares, we take the square root of the first term. The square root of x squared is x, and that goes in our first slot for each parenthesis. The square root of 25 is 5, and that goes in the second slot. And then one of them will be positive, and one of them will be negative. And then we can do our zero product law. Solve for x. So we get x equals negative 5, and we'll add this 5 over. X equals positive 5. Okay, so let's go ahead and put this in Desmos, and we will check what our turning point and our range are. Now, turning point is another name for the vertex. So keep that in mind. They are the exact same thing. Okay, so I put x squared minus 25 in there. Our turning point or vertex is down there at 0, negative 25. Okay, our range is our y values. So our y values start down here at negative 25 and they go on for forever. So this is going to keep going up. If I keep zooming out, you'll see it just keeps going up. So our lowest y value is negative 25. Our highest y value is infinity. Another way that we can write this, don't forget your equal to there on that negative 25. Another way that we write this is y is greater than or equal to negative 25. So either way is fine. We tend to see this a little bit more just because it's condensed. And so saying that your y values are greater than negative 25, that just makes sense. You can also say they go from negative 25 to infinity. That's not incorrect. Okay. And let's see, number 5. So this one has 2 terms, so it's not going to be split the middle. 4 and 49 are perfect squares, so we might be able to do difference of squares. We have subtraction in 2 terms. So let's go ahead and give difference of squares a shot on this one. The square root of 4x squared is 2x. The square root of 49 is 7. One of them will be positive and one of them will be negative. Now this is a little bit different because we have a number in front here. We haven't had that yet on numbers 2, 3, or 4. So when we solve for these, it does look a little bit different. It takes an extra step. So we're going to go ahead and subtract 7. And then to get that x by itself, we need to divide by 2. Okay, so x equals negative 7 halves. Over here, similar steps. This time we add 7 and divide by 2, and we get positive 7 halves. So 7 halves is equal to 3.5. So we're going to see that show up when we put this into Desmos. Okay, so we're looking for our roots, which we know is negative 3.5 and 3.5. You can write them as decimals or you can write them as fractions. Okay, the vertex is down here at 0, negative 49. And then that's also our y-intercept. So if you zoom in, you can see that that's where our graph crosses the x-axis at 0, negative 49.